On to number 5 is our last conversion problem. We're going from square feet into square inches. Well, that means we're actually going from 1 foot squared, and our final goal should be something in inches squared. Okay? A couple ways to do that. One is by straight converting. Okay? Just knowing that we got to get rid of feet twice and get inches twice. That means 1 foot is 12 inches. Okay? And we have to do that twice. 1 more foot is 12 inches again. That's because we need feet squared, which is feet times feet, which looks like that. That'll result in us having 144 inches squared. Now again, I said there were 2 ways to do it. That's the real straightforward math version. Another way is an old test-taking tactic that we've used in the past, not necessarily in this class, but in other ones, which is draw a picture. So if I think of a square foot, I think of a square. That is 1 foot by 1 foot. Well, I want to know how many inches there are there. That means I need to know how many inches are in a foot, and I know that there are 12, meaning this is 12 inches by 12 inches. And if it's a 12 by 12, I know that is 144 inches squared. Because it would be a grid of 12 inches this way and 12 inches this way. So it would make 12 rows here, 12 columns here, making 144 total squares. We shift down to radicals. We shift to radicals here, okay? And the first 2 are just simplification problems on their own. They don't have any addition or subtraction, multiplication yet. These are just simplification problems. So we're starting off with the square root of 900x cubed. Okay, there is some merit to trying to do this with the highest perfect square, finding that. But for most of us, we realized that it was just easier all around if we just started breaking it down into small numbers. Meaning that if it's even, like 900 is, I break it down with a 2. If you want to use a 5 or a 10 or anything, that's fine, be my guest. But I have a certain method or way of doing this that always works the same. My trees don't get all these confusing branches piled up everywhere. My trees always look the same. So 2 breaks into 2 and 450, which divides by 2 again to 2 and 225. Now is when I'll start getting a little bit, adventurous, and I see 225. I don't really off the top of my head know if 3 goes in there. I can use my trick to see that 3 does go in there, but I know 5 goes in there because it ends with a 5. Okay? So 5 breaks down into 5 and 45. Just throw these in your calculator, double check them. Which breaks down into another 5 and a 9. Which breaks down into 3 and 3. Pairs come out front, and when they come out front, they're a couple, they're 1, because they get square rooted on the way out. And square rooting is the opposite of squaring. So a single 2, a single 5, and a single 3 all came out, and that means there were no variables or no numbers left underneath. They all left. There was nothing. Next, we look at the variables. X cubed is x times x times x. That means a pair of x's are going to come out as a single x. But this time, I put a little box around it. This time, we left something behind. Okay? So 2 came out front, 5 came out front, 3 came out front, x came out front, and we left an x behind. Put it all together out front. 2 times 5 is 10, times 3 is 30x on the square root of x. Remember, you can check the number portion of these problems, even if they are ugly decimals. What I mean by that is I can check the square root of 900 and see if it's just a 30, and it is. Looks like that one we did correct. On to number 7, we have -9 out front of our radical. underneath is 216 into the fourth power, which, hey, it's an even number, so I'm going to start breaking it down with twos again. 2 breaks it down into 2 and 108, which breaks down into 2 and 54, 2 and 27. 27, I know, breaks down into 3 and 9. That's the times table, which is 3 and 3. Oh, I'm sorry. 3 and 3. See, this is what I meant by my trees always look the same. They're always nice and slanted. Not nice and slanted. I guess that'd probably be an ugly tree. But they're slanted down in this pattern that makes it fairly easy to find the pairs. There's a pair of 2s moving out front. There's a pair of 3s moving out front. And we left that 2 behind and that 3 behind because they didn't have a pair. They didn't have a matching pair. Into the fourth power is n times n and n times n. That's 2 pairs with no n's being left over. So let's tally everything up. We had a -9 out front that started out there. We brought a 2 out. We brought a 3 out. We brought an n out, and we brought an n out. What we left behind underneath was a 2 and a 3, which is a 6. We left no variables behind. Okay. Multiply everything here together, and we get -54. N times n is n squared on the square root of 6. Let me show you that trick again about being able to check your answers in the calculator. My original problem, just the numbers. We're not going to check the variables. We can't really check the variables. There's not a clean way to do it. Is -9 on the square root of 216. And that's a big, ugly decimal. But our final answer was -54 on the square root of 6. And I press enter and I see, oh, what do you know? The same exact crazy decimal. So that means we simplified 216 with the -9 out front correctly. The only thing left to do is make sure you had the variables right. 4 n's, that's 2 square root pairs, they come out. Number 8 is another radical problem, and this time it wants us to subtract them from each other. And that's great, except for we know we can't add or subtract, or not add. We can't subtract stuff and add stuff unless they're like terms. So we start off with -2 on the square root of 24, -4 on the square root of 96. We got to break these things down. 24 breaks down into 2 and 12, which breaks down into 2 and 6. I see a pair of 2s here, and that 6 is going to break down into 2 and 3, meaning that 6 is just going to stay behind. Now, because this is a test, okay, because it's a test, I can already tell you what number I'm expecting to see right here, and I'm expecting to see this break down and leave a 6 behind. Look at the answers. They've all got square root of 6 on them. So if you're breaking these down and you start getting crazy other numbers, pause, go back, and see where your mistake is. 96 breaks down into 2 and 48, which breaks down into 2 and 24. Now we're kind of in familiar territory. 2 and 12, 2 and 6, pair of 2s, 6 stays behind. Because again, that 6 actually breaks down into 2 and 3. You'll see this pair, this 2 doesn't have anything to pair with, and the 3 doesn't either. So they essentially both stay behind as a 2 and a 3, which becomes 6. You put them back together. Okay? Please, I had students trying to do this, trying to say, oh, there's a 6 there and a 6 there. These are very separate breakdowns here. Okay? Please do not let them overlap too much. This 2 came out front. It multiplies here to be a -4. Square roots of 6. 2 comes out front. 2 comes out front. -4 times 2 is 8. Times 2 more is -16. Square roots of 6. Now I can combine them because they are like terms. They have the same radicand. -4 minus 16 is -20. Square roots of 6. I'll go up here, double check. There's my answer. Number 9 really is the easier of the two. It probably should have come before Last problem, but it is a little tricky because you have to remember what happens when things aren't there with radicals. -2 square roots of 2 minus square root of 2. Well, they have the same radicand, which means I can combine them. But there's a hidden number out front of 1. -2 minus 1 is -3 square roots of 2. Remember, it's just like with a variable. If I had -2x minus x, you'd say, oh, you just add the numbers out front. And that means it's -3x. The x didn't matter, it didn't change, it just made them like terms to determine whether you could do it or not. Okay? 10 and 11, finishing out our radical section. This is where things go different. All right? Think about it like variables. I can't add 2x plus 2y. I can't do it. But if it were to be 2x times 2y, that would be 4xy. Like, so you can multiply things that you can't add sometimes. And that holds true again with radicals. If I want to multiply this square root of 3 into this binomial, it is distribution multiplication. And we learned a little thing here. We learned out times out and in times in. What that means is outside numbers times outside numbers and inside numbers times inside numbers. Well, that means you need all your outside and inside numbers. This one's missing a front number. It's a 1. It's got a radical. This one's got a front number, an outside number, and a radical number. This one's missing its number out front as well. It's outside number, so it would be a 1. Now it's time to distribute. Outside times outside is -4. Inside times inside is square root of 15. Outside times outside is +1. Inside times inside is square root of 9. I look up here, I don't see that answer up here anywhere, okay? And that's because I've still got to work with this 9 here. 15 breaks down into 3 and 5. That doesn't break down any further, so there's nothing I'm getting out of that side. But 9 breaks down into 3 and 3. Which is a pair of 3's coming out front and no number or variable being left behind. Meaning my final answer is -4 square roots of 15 plus 3. My apologies for the bell. That one's going to be done. Again, you can check your answer. Plug the original into your calculator, get a crazy decimal. Plug your final answer in the calculator, see if it's the same crazy decimal. If you did the problem right, it will be. Number 11 here. We're again multiplying. We've got outside numbers and outside numbers. We've got inside numbers and inside numbers. We're good to go. This one just has variables. So my first multiplication, outside number times outside number is -8. Inside number times inside number is 16 in cubed. 16 in cubed. Well, I look up here and again, just like last time, I don't see anything that's matching. Now, if you're being clever, I'm going to go ahead and say it's probably this one because I don't see any reason my signs are going to flip, and it's the only negative. But if you don't pick up on that, that's okay. We see that 16 is a perfect square of 4, meaning we're going to have a 4 come out front. That's -32 now. In cubed, that's a pair of n's that come out front as a single 1 and 1 that gets left behind. Should box it. -32n on the square root of n.